presently I am pursuing PhD at Department of Mathematics in the district IIT Kanpur. I am a PMRF fellow right now. Before that, I was a CSR fellow, and I have cleared my CSR net with 108 rank. Okay. So today we are going to discuss about conic section. So what are these conic section? What we will discuss in this chapter? So in this chapter we will go through. So this chapter we will go through circles, parabola, hyperbola, ellipse, and all these things. So before going further, we should know about the why we need to study this geometrical things, like why we need to study these conic sections. So first of all, just recall one fact that whenever we go to some stadium to watch some cricket or football match, then we sit in a stadium which is of the form square or circle or some not exactly circle, that is in the form of ellipse. That is one side diameter is higher, then other side is little lower, like this. So for that purpose, how we can construct that stadium or how we can construct that field, we need the circle. Again, if you you all have seen the how a headlight of the car looks like, this is a little bit of the form parabola. Okay, so all these natural phenomena are very much related to this circle, parabola, hyperbola, ellipse, and all these things. So that's why we need to study these conic sections. So before going further into the particularly one of the circle, parabola, hyperbola, ellipse things, we should understand how we can geometrically obtain this circle, parabola, or hyperbola, or ellipse. Okay, so let us assume that this is a straight line, and this straight line is fixed. This is fixed at this point. Now I have another straight line. Okay, and this point is also fixed. This red point is also fixed. Now I am saying that keeping this L point fixed, L's straight line fixed, rotate this blue line, rotate by how much reason? 180. Okay, that is one complete rotation. Then what we will obtain? What we will obtain? If we rotate this blue straight line 180 degree, then we will obtain like some this kind of figure. Con- no? Okay. So after the complete rotation, you will find some kind of this kind of figure. Okay. So now after completing this complete rotation, so whatever we geometrical object we get, we call this as cone. That is, we are like this is one cone. You can clearly see that this is one cone. The yellow portion is one cone, and this different color. This purple portion is another cone, right? And you can clearly, and you should understand one thing, that this portion is void. There is nothing. Like it is a void cone. Like you can understand that by you have two scoop of ice cream. Only not ice cream. You have just the two scoop, and you join the um, these parts together. That's all. That's thus you get this kind of thing. Okay. Okay. Now understand one fact, that this is maybe this is angle alpha. If this is angle alpha, then this is angle alpha. This is also angle alpha, right? And for each for each point, like if I have a line at this point, suppose at this point, because it is rotating, so at some point it will come to this position. Obviously, it will come to this position like this, and at that position also, the angle will be of alpha. This will be alpha. So you need to imagine that we are working on a 3D object. This is a three-dimensional object. Okay. So this is called a double left, right, circular cone. Okay. This is called a double left, right circular cone, where this green line is fixed, and this is called the axis of the cone. This double left reticular cone is called the axis. Okay. And this alpha is an angle which is this is called upper nap. This is called the upper nap. This is called this line, this blue line, or you can see here. This is called generator. This is called a generator. Okay. And this point, this V point, is called vertex. Now note that this vertex separates the these two cone into two parts, which are called upper nap and lower nap. Okay. Now this is the conic. This is a double nap reticular cone, and this is the conic. Now we need to understand the conic section. Okay. Now we will go to the conic section. Conic section. So let us redraw this figure again here. Here the fixed axis, which is not moving. Here it is L. Now you have the moving part, moving generator, moving line, that is this straight line. And this is rotating. Okay, so this is rotating, and for each position, I am assuming that there is a position like this, and then circle, and the generator blue line, it is rotating. So we can think of like that two ice cream scoop like that, join at the top point, right? So you can think like that. It will be you, or you can there are some. As far I know, there are some music instrument which look like this. Okay, so you can think of like that. Now, I have a plane. Suppose I have a plane. Recall that we on this angle between this generator and the axis was alpha. Now I have a plane. Suppose I have a plane like this. The dotted line denotes here the portion in the background of this conic. So for that we should join this because this is not dotted. I just dotted this line because you should understand this at this point. Once this generator achieved this point and again it went like that. So that's purpose I have like this as a join as a point. But now I am joining this line to understand properly because I am denoting this dotted line for the background of this connection this double lap conic. So for that purpose I am joining this line. Yeah, I am getting this one. And again, the back portion will not be dotted because that is in the back portion. We can't see it from the front. We can assume that there will be some kind of this thing, but that is we can't see from the front. So yes, I have a plane. So suppose this is the plane which cut this double left right circular cone. Okay, so clearly you can see that this from this point we can see something. So how can I understand what is the angle of this plane with this line L, which is the axis? So for that, we can draw a line from here to here, like this. We can write, yeah, some down line, okay, like this. So this is the line on the plane which passes through the axis of the cone. Okay, so clearly this makes an angle with this axis, right? Suppose this angle is beta. This angle is beta. Now, depending upon this measure of beta, we can find different geometrical figures. How? Okay, let's check here. By some small example, we can check. We can by geometrically drawing, we can check that how we can obtain those geometrical objects. So before that, we should understand what is conic section. So by conic section, what we mean? The conic sections are the curves obtained by intersection of a right circular cone by a plane. Okay. So what is conic section? Conic section is the curves which obtained by intersection of a right circular cone by a plane. Whatever we have discussed here. So what is conic section then? Here you can see that if this plane cuts this cone, then we can get some kind of figure like this. Some kind of figure like this. So maybe this color is giving some confusion. So I can use some different color. Okay. Sky color is green color, not green color. Orange is there. So orange we can use. The plane on the plane like this. Okay. So this line is called a conic section. Note this part. Okay. So this is called the conic section. It is called a conic section. Now, depending upon this angle beta, the shape of this conic section will be changed. Also, you can see from here also, here only, but I will draw some more figures so that you can clearly understand how and when this figure is gonna change. So let us draw the first one. See the fixed axis. See the conic section, the right circular cone, and say this, 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 this. Fine. Okay. Now suppose beta equals to 90 degree. 90 degree means that axis and the plane should be perpendicular here. Like the axis should be perpendicular in a plane. In that case, the plane should be like this. If you little bit understand it as a 3D image, you can clearly see that this angle beta here is clearly 90 degree. Let us see this angle. This angle is 90 degree. In that case, the conic section will be like this. Okay, so maybe from this view, this from this view, it is not that much clear. Okay, the case this will be some kind of thing. Okay. Now this point of view, maybe this is not that much clearly visible, or you can see this how this is a circle. So if you see from the top of this conic, then how what will be this? So like this, we can draw the figure something like this. Okay, so this is our plane. Suppose this is our plane, and due to this conic section particularly, so if we see from this top position, we reach top position, then we will see like this. Whatever we can see, I am drawing that first only. So you will get a kind of this thing here, right? And from here, it will be looking like this. There it is dotted because it is inside the phone, so you can see from here. Yeah, and this blue part, this blue of this top, it will be like this here, right? And the green part, this green line will be some kind of dot here, right? We just try to understand this fact that I am watching from the top position, from the top position of this right circular cone, to understand that how this circle looks on the plane. Okay, how this circle looks on the plane. So if beta equals to 90 degree, then we can find this circle on the plane, which is intersecting this reticular cone and this plane. Okay. Now, what if beta is less than 90 degree but greater than alpha? Greater than alpha. In that case, again, draw the picture. Okay. Now, here alpha was this angle. Here alpha was this angle. Here also alpha will be this angle. This is the vertex V. Okay. And here also you can see the vertex will be here. Vertex V will be here. Okay. Now, there is vertex V and alpha is this angle. Now, draw a plane which is in some angle which is less than 90 degree but greater than alpha. Check that. Okay. So this is the plane. And suppose just for drawing purpose I am writing these dotted lines. understanding these things, this makes an angle beta, right? Now clearly you can see the beta is less than 90 degree, but this beta is greater than alpha. Okay? In that case, we obtain a geometrical figure which look like this. So how it looks in the plane, I am not drawing the other parts, so I am just drawing the plane and only the figure. So the plane will be like this. And the figure will be like this. I am not drawing the blue sections and all these things. This is the green straight line. It is top view point. You are watching this all on the position from the top view. So by this you are seeing like this. This red one is vertex, green one denoting the axis of the cone. Okay, and this red portion is the called plane where you can see the sphere, the ellipse. Okay, so if beta is greater than 90 greater than alpha, then we can see this kind of figure. Now, what if beta equals to alpha or beta equals to alpha? Beta and alpha is same. Okay, in that case, what will happen? In that case, we can see two different type of cases. So let's start a new page. Up to the I hope this clear. This is the green line, which is the fixed axis. Okay, and in that case, here alpha is this angle, and the plane is also with the same angle of alpha. The plane makes the same angle with alpha. In that case, this plane should be parallel to this line. Why? Because this line makes an angle alpha with this green line, and the plane is also making an angle alpha with the green line. So obviously, this line and the plane will be in parallel position, and you can think of like this line plane can be parallel to this also. So that's why I am making some different cases so that you can understand properly the different scenarios. Okay, so I need to draw 2 3 pictures for this thing. Okay. Just for trying purpose, I am drawing like this. Don't get confused that this line is a complete 3D picture. Okay, so I draw the middle portion, middle line of this whole thing. Then I can see this portion will be like this. Cut at angle alpha, not angle alpha, right? So in that case, you can find that we find some kind of figure like this. End of this. Not exactly I am saying that this will be the exact figure, but yeah, the figure will be something like this. And if we draw this in the plane, you can see it will be something like this. Okay, something like this will be there. And here the green light should be something here, and green light should be something here like this. Okay, this kind of figure I will obtain from here. Okay, and also this figure can be little bit drawing a little bit like this. It will be a little bit more get to understand properly, much more clearly. Or also you can make this whole plane with respect to the another line like this figure. I'm drawing another figure for this uh, image. This is the fixed axis. This is the blue one. This is the blue one. That is the conic, you can say. And here I am drawing the plane like this. Okay. So this figure is much more relevant. You can understand that how it is working. Okay. I can draw a little bit much more beautiful so that it looks like. So from there, you can clearly see that this is a conic, this is a plane cutting is like this, and this is obviously parallel to this angle. How? Which angle? This angle. You can see this angle and this angle are same angle. Both are alpha here, and this makes an angle here like this. This. Okay. So thus we can find the parabola. So after this, we have obtained three kind of conic section. One is circle. Another is ellipse. Ellipse is nothing but circle. Circle is a different shape, or you can see that circle is nothing but an ellipse with both side equal, both length the diameters are equal. And in this case, for the case of this, we obtain a parabola. Okay? In that case, we obtain an ellipse. Let's right. We obtain an a circle. Here we obtain an ellipse. Here we obtain a parabola. Now from here, you can ask one question, that is it possible that this plane cuts the both the conic section, both the conics, and it is double left conic. So it may happen that this plane cuts like this, that it cuts both the conic. So up to beta equals to alpha, like up to this section, up to when beta is between 90 degree and alpha, then the plane couldn't cut the both the conic section together. If they at most they can touch, and that will be given only a straight line. Like if this thing happen like this, like if I say one more example, if I draw another thing, then you can understand this. Like okay, I'm drawing in smaller person. Okay, see the fixed line, see your blue line. Okay, and somehow we can think of like this, that this plane touches both the conics. Okay, then you can clearly see that whenever this plane touches this both the cone, and if the angle between them is less than equals to alpha, at most it will be alpha, then it will give at most this straight line. That's all. Nothing more than that. If condition is if beta equals to alpha, and if beta less than alpha, if beta less than alpha, then plane will not intersect both the fronts. Sorry, both the fronts. Fine. You can draw this by your own. Only this section I will get if the plane cuts like this. The angle will be of the form alpha, and we cut both the fronts. Fine. And if it is not like that, then we will get an parabola, or before that we obtain that either ellipse or circle. Now, what if beta is greater than alpha? Suppose beta is greater than alpha. In that case, let's draw the figure. Okay, and now the plane, it is the Mexican angle alpha here. Okay, and now I am drawing the plane, and in that case, the angle will be less than alpha, right? Just greater than alpha case was done. Now it will be less than alpha. The less than alpha will be then like this. The plane will be like this. Okay, like this. I will cut the plane. Okay, so clearly, if I draw the middle point from this case, it should be like this. It's a line passing through the middle of the plane. Not it is not now not present in the middle right now. It means something apart. Okay, so let's assume that this is the middle of the plane, and it passes to the vertex, and it makes an angle beta, which is obviously you can see by this figure less than alpha. Correct? Then you can clearly visual these things. It is not that much easy to elaborate with all these 3D figures in a 2D plane by just drawing. I will recommend you all that you should go and search in YouTube the conic section, and you can understand by some geometrical figures uploaded in the YouTube. This is you can try to understand from here. Otherwise, you can go to the YouTube so that this will be much more convenient to understand how this conic sections is coming to the intersection of a conic, right, of a conic and a plane. Okay, so here you will get something like this. By addition, this will be like this only one, and another will be like this. So if we see from the top of the figure on the plane, it will look like this. If it is a plane, it's a plane. It will kind of look like this, and this is known as hyperbola. So you can write that we obtain a hyperbola. Fine. So up to this, we have discussed about some conic sections. Okay. Now let us study some degenerate conic sections. The next section is it. Degenerated conic. Okay. So what is the difference between before and after in this case? So in this case, the considered plane will pass through the vertex V. Pass through the vertex V. So what is the vertex? Vertex is at this point. Okay, different color will be okay. Green, okay, purple. This is the vertex. Here, this is the vertex. This is the vertex. This is the vertex. This is the vertex. All these cases is a vertex. This V denotes the vertex. Fine. Is all these V for vertex. Now, among all these figures, I am scrolling down all this to all this figure. You can see one such case I have already discussed between them. But let's go through the first from the first. So here I have discussed about the double left right circular cone. After that, I have discussed that when a right circular cone is intersected by a plane, how it will look like. So here it is the image. After that, I have discussed depending upon different angles made by this plane and not passing through the vertex. You can see from the image only that this plane is not passing through the vertex. But here I have gone through one example where the plane passing through the vertex. Already of this. So here you can see okay, you can get parabola, here you can get another parabola. But here I am getting a straight line, and yes, you can see that here the plane passing through the vertex. You can clearly check that thing. Here the plane passing through the vertex. That's why instead of parabola, we obtain a straight line. Okay. So let us discuss another cases of this degenerate case. So one degenerate case already I have discussed. So let me draw it again once a little one bit. That is the fixed line. And you can think the conic. So this is the vertex. Purple one is the vertex, and the plane passing through this point. Then it look like this. It should be parallel to this line. And this angle is equals to alpha. Okay. And if I draw the middle line, it will be like this. And clearly you can see that the intersection line is with this one. And in this case, both the angle will be same, alpha equals to beta. Alpha equals to beta. Now, what if beta equals 90 degree? Okay, let's draw here. Green line again. Okay. The plane is at 90 degree and passing to the vertex. Okay. The plane is of 90 degree. I mean, the plane makes an angle 90 degree and it is passing to the vertex. So the middle line will be something like this. The vertex will be this point. So this clearly can be seen that it makes an angle 90 degree with this uh, green line, which is the fixed axis. So here we obtain a point, only a point. Okay. Now, also, you just check one thing that up to alpha equals to alpha up to beta less than alpha, that is for text and color for beta less than equals to 90 degree greater than alpha, you obtain a point. Obtain a point. Why? Let's draw a photo again, which is passing through the vertex and making some angle less than 90 but greater than alpha. So alpha is the angle you know about this. Alpha is the angle alpha, and the beta will be the angle this. In this case, also beta is always 90 degrees, so it is greater than alpha. And now I am saying about the case for beta is less than 90 but greater than alpha. In that case, the drawing will be like this. Okay, let's imagine that is beyond these things. Okay. Okay, and here you can see the plane is here, but the angle is something different. Passing through the vertex. With the vertex, and clearly check that this angle is alpha and this angle is beta. And here beta is less than 90 degree greater than alpha. Here also you obtain a point. Obtain a point. When okay, when we have beta and alpha equal, alpha equals to beta, in that case we obtain a straight line. Here you can see this first figure. Okay, so up to beta less than equals to 90 degree greater than alpha greater than equal to alpha, we have done. Now what if suppose beta is less than alpha and passing to the vertex, the plane is passing to the vertex. Okay, in that case, Okay, and the plane is like this passing to the vertex. So let's wait. Okay, the plane will be something like this, passing to the vertex. Okay, let's not drawing this thing. You can understand that this is background. This is working in the background. Okay, and this is the middle point. And if I dotted this line, then clearly see this angle is less than alpha. This angle is obviously less than alpha. This beta is alpha and beta is less than alpha. So in this case, this is the okay. There's a mistake in the drawing. The middle portion will be passing to the vertex here. Should notice that this should be partitioned to the vertex. I have drawn something wrong in that first only. The relation will be like this. This vertex point will be touched. Then again, it will be go like this. We need to understand this fact passing to the vertex. In that case, we will get two straight lines like this. One will be like this, and another will be like this. You can draw it by yellow color also, the black yellow. To understand this, there are many colors, so properly understand this is a black yellow. But it will be the intersection of this plane with the cone, double cone. So I will not go much further today, but I will stop here only. So you need to go through all these things so that you can get convenient after this lecture, so that you can understand properly what geometrically happening when the plane intersect the conic in different position with different angles. Okay, so this is called like degenerate parabola. I can state like this. Okay, sorry, degenerate tissue hyperbola. This is called like degenerate tissue hyperbola. Degenerate case of hyperbola. That, that, degenerate case of hyperbola. Okay, why it is degenerate hyperbola? Because in case of hyperbola, you can see that the both that we can have we must have two-sided curves. In other cases, we only get only one curve like this, only one neighbor curve we are getting. But in case of hyperbola, we are getting two curves. Now, if I join these two curves like this, just draw in black. It will be then you can understand for a little bit. If I join these 2 points, right, and make this a straight line, then I will get like this. As soon as this plane, this red plane, passing to the vertex, as soon as passing to the vertex. If it is not passing to the vertex, then we will get that yellow curve. If it is passing through the vertex, we will get these two straight lines passing to each other. And this is called the degenerate version of hyperbola. Okay, so this is how we can obtain a different circle, ellipse, parabola, hyperbola using a plane and a conic, and by this section of these two, one plane and one conic. So that's why it is called a conic section. And we have today we have discussed about and we have seen how we can obtain this circle, ellipse, parabola, hyperbola cases, and how we can get a straight line. When we will get a straight line, when we will get a plane, when we will get a point, and when we will get a two straight line intersecting at each on one point. So that thing we have discussed. The next day we will discuss this geometrical figures explicitly, and we will put some focus on those topics. So today we will stop.